Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning about rectangles and what its properties are. So let's get started with the following problem that will lead us into today's lesson. On a parallelogram, ORTH, measure of angle O equals to 3z plus 15, and measure of angle T is equal to 4z minus 10. Compute the measures of all four angles of this parallelogram. The first thing we want to do here is draw a parallelogram as shown in the figure and label whatever we have available, in this case measure of angle O and measure of angle T. Now, what must be true about parallelograms, or which property of a parallelogram can we use to solve for the value of z first? Well, from the previous lesson, we learned that opposite angles of a parallelogram are congruent. From that, we can deduce that angle O is congruent to angle T, and therefore, measure of angle O equals to the measure of angle T, because that's just simply the definition of congruent angles. Let's now substitute. Here we can say that 3z plus 15 is equal to 4z minus 10, and so we get a value of z to be equal to 25. The question is asking us to compute the measures of all four angles of this parallelogram. So after substituting for z equal to 25 into those respective expressions, we obtain a measure of angle O to be equal to 90 and measure of angle T equals to 90 as well. Now, how do we find the angle measures of H and R? Well, we know that consecutive angles must be supplementary in a parallelogram. So namely, the measure of angle O and measure of angle H, those two angles add up to 180. So the only plausible answer here for measure of angle H is also 90 degrees. And therefore, measure of angle R in a similar manner, since angle R and T are also supplementary because they're same side interior angles and they add up to 180, measure of angle R is also 90 degrees. Notice that this parallelogram is now not drawn to scale anymore. Well, what kind of shape is this? So let's fix this parallelogram. So our image in reality looks like this. This parallelogram would be a rectangle because all the vertices are right angles. So that's really the introduction to today's lesson, and maybe with this particular do now, we can think of the definition of a rectangle somehow in terms of the parallelogram, but with one specific condition. So let's get to the definition now. So here's the definition of a rectangle. A parallelogram is a rectangle if and only if the parallelogram contains a right angle. Notice that the definition does not say that a parallelogram contains four right angles, but it is sufficient to just have one right angle to state that the parallelogram is a rectangle. One more thing to know is that a rectangle is defined in terms of a parallelogram. So basically, what we can say that every rectangle is a parallelogram. Okay, so now that we have defined the rectangle, let's now discuss the properties of the rectangle. So let's list them all out. Okay. Since we know that a rectangle is a parallelogram, or as we noted previously, that every rectangle is a parallelogram, it automatically inherits all the properties of a parallelogram. So then we can write the following as the first property of a rectangle: that the properties of a parallelogram are all the properties of a rectangle. Let's review those. But notice that now we can actually change the word from parallelogram to rectangle. If you say parallelogram, it's still correct because a rectangle is a parallelogram. So let's change those words. Okay, so now we can say that a diagonal of a rectangle divides the rectangle into two congruent triangles. Consecutive angles of a rectangle are supplementary. Opposite angles of a rectangle are congruent. Opposite sides of a rectangle are congruent. And the diagonals of a rectangle bisect each other. Okay, so these were all the properties of the parallelogram. We just changed the word from parallelogram to rectangle. Now, are there any additional properties for rectangles that are not applicable to parallelograms? The answer is yes. One additional property is that all angles of a rectangle are right angles. As a matter of fact, it's also called an equiangular polygon. And finally, there's something else that can be said about diagonals. Okay, if we, for example, draw diagonals from O to T and from R to H, it turns out that these diagonals are also congruent. As a matter of fact, as an additional property of a rectangle, we can state that the diagonals of a rectangle are congruent. Notice that this is not the case for parallelograms, okay? Now, it turns out that the first property, which basically are all the properties of the parallelogram, we already proved them in one of our previous lessons. Number 2 does not require a proof because it's already entailed in the definition. Well, in the definition, we're only stating that there's only one right angle, but then we can use the fact that consecutive angles are supplementary to prove that all the other 3 remaining angles are also right angles. So that's an easy proof. The third one states that the diagonals of a rectangle are congruent. Let's prove that one now. Okay, so here we want to prove the property that the diagonals of a rectangle are congruent. Let's say we have the following image here, and we know that ABCD is a rectangle. How do we prove that segment AC is congruent to segment DB? Well, let's get started with setting up a statement reason table and stating the first given. Okay, so once we stated the first given here, what else can we state? Can we use any of the properties developed previously in proving this? Well, what we can do here is look at triangles ACD and triangle BCD to prove those 2 triangles congruent, and then use corresponding parts of congruent triangles are congruent. Okay, so to get started, we can, for example, state that these 2 sides, the opposite sides, are congruent. For example, that segment AD is congruent to segment BC. So let's write that in. Okay, so what's the reason for that? Well, we know that this is a rectangle, okay? So we know that in rectangles, opposite sides are congruent. Okay, so let's write that in now in the statement reason table. So once we wrote that in, we can now refer to segment CD and say that this segment is congruent to itself because that is a part of both triangles. And that is the reflexive property. Okay, what else can we state? Well, here we can now state that angle ADC and angle BCD are right angles, as shown in the diagram, because all angles of a rectangle are right angles. Now, since they're right angles, now we can say that all right angles are congruent, and therefore angle ADC must be congruent to angle BCD. Okay, so if we look at the proof now, it seems that we have all the ingredients to prove that those 2 triangles are congruent. So let's write that in. Triangle ADC congruent to triangle BCD because of the SAS postulate. So how do we know that segment AC is congruent to segment DB? Simply because corresponding parts of congruent triangles are congruent. And that's basically it with this proof. Again, let's review what we have learned in today's lesson. Okay, here's the summary of today's lesson. Today we learned about rectangles. First, we learned about the definition of a rectangle, as you can read here, and all the properties of a rectangle. Note that every rectangle is a parallelogram, and it therefore automatically inherits all the properties of parallelograms. Okay, so that's basically it for today's lesson. Again, thank you for watching and have a wonderful day.